Agentics Foundation Tokyo event. And thank you very much to many of you here. Anthony, who really supported us making this happen, and Professor Toshiya, Jean-Marc, being one of the very first, connecting us with 42. And of course, our Toronto team, Ruth, Brad, Rob, Nick, putting all the material together. So thanks again. And with pleasure, I would like to introduce to you the founder of Agentics Foundation, Mr. Reuven Cohen. Reuven, you want to say
Hey
hi?
everyone. Yeah, hey, nice to see you, everyone. Haji Mamashite, uh, and
Uh,
thank you.
yeah, one quick thing about Reuven is that he doesn't look Japanese, but he's half Japanese. Um, I'll leave it to you, Ruv, to talk about it. But Ruv is a globally recognized AI pioneer. He has done so much work. If you go to Reddit, LinkedIn, you Google him, you'll find out a lot of his work, and also some of his work being downloaded, so many times. They're like 500,000 downloads a month. Um, so Ruv gonna do the opening as well as a keynote. He will show us what agentic AI can do. So Ruv, it's all yours.
All right. Well, thank you for having me today. Let me share my screen
Yeah, please do.
and tell you a little bit about agentic engineering. Okay. Hopefully this works. All right. And if you have any questions, you can feel free to interrupt me. I don't mind. I'm Ruv. Let me just go full screen here for you. Uh, all right. So I'm Roof. I'm the co-founder of the Agentics Foundation. There's a number of co-founders on the call today as well, with Robert and Nick and Brad, who have been sort of part of the initial idea to build an organization dedicated to what is now being called Agentics. And the concept of Agentics is something that we've been working on for a while, and it took a number of years for the rest of the world to really catch on and see that there was opportunity in building agents that could operate with little but some human intervention, a kind of cooperative between what's possible when using AI to do more, while also having a ability to understand it and work with it in a way that's beneficial to the people who need to interact with it. It's not to replace, it's to make us better, more capable versions of ourselves. So the concept of agentics comes from the English word agent or agency. So in English, agency represents the idea that you can think and operate and understand on your own. You have agency. You have your own thoughts. You have your own abilities, and you have the things that you're interested in, and the things that make you scared or whatever it is that makes it you. That's your agency. Now, when you look at applying agency to technology, it's not like a person. It's like the concepts of having systems that can operate with little to no human involvement, depending on the context, to know the difference between good and what's bad, what's right and what's wrong, and other sort of autonomous or automatic operating components that you put in a company or different environments. So think of things that run by themselves, that are capable of perception, seeing what's around them, reasoning, thinking why and what is around them, and action, what they should do about those things, and capable of executing on those things. So when you think about this technology, there's four pillars that we generally look at, and this is similar to the approach you'll see with self-driving cars. In a self-driving car, you have different levels of autonomy, the ability for the car to drive by itself. In the same way, a AI agent has the ability to be driven, but with the sort of cooperation or friendship of a person or with no involvement from a person. So when you look at what it needs to do to make that happen, you have this idea of a proactive. And again, the idea of proactive is it anticipates, it predicts what's going to happen, and rather than reacting after the fact. Traditional software is reactionary. It reacts to a problem based on a certain set of guidelines that it needs to operate within, but it's never going and proactively thinking what may happen later. And that leads us to autonomous, which I mentioned earlier, the ability to operate independently and to be able to make its own decisions and understand. Then the next important part is the collaborative feature. These systems need to be able to cooperate not only with the people that are guiding these systems, but also the other agents that need to collaborate with them to get different problems solved, like coding a website or operating a factory, different types of things. And that's where you get targeted. Targeted is having narrow focuses of the agents. Each agent shouldn't try to do everything. You shouldn't create an agent that looks at operating an entire company. You might want to create many thousands or millions of agents that do very small parts of each of those companies, not even a full entire job, but a very small part of that job. And that's where the targeted part becomes very important. So our organization is dedicated to this. It's dedicated to the idea that agentic engineering is not just the random creation of things by asking ChatGPT. The foundation is we can use this technology to build better, more functional, more capable, and more intelligent systems. And that requires knowledge and know-how and a kind of engineering mindset. The idea that you can create a process that's repeatable, an architecture that's understandable, and a core philosophy that this technology makes us better and more capable to those that we work with, those that we love, and so on. So it's a kind of guild of sorts for those who believe that this is a new form of work, I guess you'd say. And that's what we're looking to do. So the Agentics Foundation was founded, I think it was March of this year, so we haven't been around very long, but the ideas and the things that we're creating are on the cutting edge. Lots of stuff that we're doing here. One of the things you hear a lot of, and I want to jump in this quickly, because we love vibe coding. And often a lot of people think when they hear about AI or agentic driven coding, they think garbage, it's bad, it doesn't work particularly well, it's full of errors and security problems. And yes, that is all true. But it's also the ability to learn new things and discover the undiscovered. So when you look at there as a sort of spectrum, from left to right, on one side you've got this idea of vibe coding. I'm learning, I'm discovering, I'm creating new things just because I can. And then on the other side you've got this idea that I can build with purpose, with architecture, and to create something that I want explicitly developed, created for purpose. And that's agentic engineering. All right, I'm going to jump. How are we doing for time here, guys? I think it's the middle of the night here, 10 minutes in. All right, I'm going to show you some vibe coding. So I want to start simple. And one of the interesting things about vibe coding is you can mix and match. And one of the easiest places to learn how to vibe with the most power. So there's a spectrum of different applications you can use depending on what you're looking to do, AI based. And at one end you have things like Lovable. Lovable, we love Lovable. Our AI Agentics crew, I think, were one of the earliest users of their technology. But it's really good at creating UIs and experiences and websites. But if you want to create really groundbreaking and novel things, what you can do is you can go into Claude Code. And so Claude Code /code it was released about a month ago, and they allow you to create full operating environments. So you've got a few things you can choose, your different models here, Opus and so on. You can also add environmental variables. Make sure you choose full. That gives it internet access. If you don't choose full, you won't have access to other APIs and other services, and that's the most exciting part of this. You can put in keys if you want to use cloud services or other things here. And so, and then you're good. Now, what's interesting is you can mix and match different things on this platform. So if you want to explore a language model or you want to try the latest agentic system, maybe LangChain or Python or Rust, whatever the environment that you're interested in, you can really just ask the system to do that. So what I end up doing, I end up creating these kind of mixtures of things that I built that all lead to new and exciting sort of packages. So let me show you a few of those. So before I do, I want to show you some of the things I built. So right now, today I'm working on a new LLM. So in this case, this is my one of my GitHub repos. So everything I build modularly as packages. So I can go in here and mix and match the different parts of the system I have. So this would be a language model that automatically learns and adapts and takes a really small, dumb model and makes it really smart. Now, that's just a subpart of a much larger series of applications that I've built that I can plug in. So if I want to infuse a database and make that smarter, I can use my Root Vector Postgres, which is a pop-in component for Postgres that basically just makes it smart. This is also a sub-project of this. So I'm creating targeted pieces that you can plug in and use in different ways. So in this case, if I want to use this, I can install the npm or run it through an npx command. So this is built in Rust, so it's really fast. It allows for vector-based database as well as graph-based structures like Neo4j. It's got a graph learning system that allows it to create and learn new things automatically by itself. Whatever you point it at, it can basically do simulations and learn. And it's got a whole lot of other things as well. So now if I want to try that, all I need to do is go back to Claude Code here and say, create me a self-learning agent that simulates the entire Toyota Motor Company in Japan. Every employee and supply chain partner, and I'll say everything. Use the MPX Root Vector system and npm, and that's it. That's all I'm gonna do. And I'm on one of my vibe casting. So I'm just gonna go here. I'm gonna click OK. Now, what's going to happen, really simply, is I've built a separate module, something I've already built, and I'm basically saying do something more interesting with that thing that I've already built. This is classic vibe coding, right? But getting from the point of like where I'm just discovering new things to something that I can use and other people use is a matter of architecture. And when you look in these types of environments, specifically mine, you'll see a folder called docs. The docs in this folder, it may be a little messy at times, but no, this is a pretty clean one, luckily. You'll see that all the parts that went into actually building the actual application. This is a really complicated application. You'll see things like the latent space or the research I did to create the Postgres integration. Lots of different things. And each of these makes up research that allows the system to follow and build things, whatever things that you want to build. So you can see in this case, I've got a folder called GNN. This is my master plan to create a next generation graph neural network. And a lot of the intelligence that I'm building in these systems are based on not on the concepts of a language model, but a graph and applying attention within the index of that graph, making basically data and vector smarter. And this is the research that underpinned what I want to build. So I'm reviewing it, I'm building it, and then that goes and creates a whole variety of different crates and packages. So in this case, you'll see in the package folder, I've got packages for super small algorithms. I've got attention. The attention one is an interesting one. This one allows me to go and look at different forms of AI. So the way AI thinks is based on something called attention. This allows me to use multiple types of different attention models within the structure and kind of mix and match and play with how those different systems work. And in turn, that allows me to optimize my agents that need to understand and learn differently. So you might use one of these for a certain type of position in a company or a trading bot, and you might use another form of attention for some kind of introspection or something it's doing a different task around industrialization or something. Lots of mixing matching. So you can see this in my repos. The repos are meant to be a kind of guide to how you can build. Now, what we're doing here in a few weeks is we're taking all this stuff that we're doing and all these things that we're building, and we're going to put together a media gateway hackathon with our friends at TV5 US, Google, and Kaltura. Google is graciously supporting us through giving us some I guess some cloud services. So thank you, Google, for that. And TV5 has given us a purpose. So they came to us and said, how can we build for 500 million French language viewers, and how can we give them an experience that takes the 30 minutes they spend every day figuring out what to watch and make that less and more enjoyable and more obvious. So you can see that the previous technology I was showing could form the basis, if you want to, for solving how do you scale to 500 million users and simulate each one of those users and understand what they want to watch every night. So this is a hackathon. We're going to be doing it on Friday, starting this week. Rob, I'm sure, is going to get into more in details there because he's been sort of leading a lot of the efforts here. And if you're interested in joining, go to the agentics.org hackathon page, and you'll be able to get up to speed and enter. I've already entered, so I can't click the button. And for participating, we're creating a global sort of DAO structure where if the TV5 guys or someone else wants to license the collective work of the hackathon, we share in all the sort of benefits to anyone who participated in the hackathon. So it's kind of a unique way to give back to anyone. And you don't have to be the winner. You just need to be a participant. And we're hoping that whatever we create is groundbreaking enough to wow and amaze the Googles and TV5s of the world. And through that, we will license some of the technology and share in the proceeds, which is, I don't think anyone's ever done before. So, yeah, that we're trying something new. And we'd love to have you involved. All you really need to do, go back. You see, while it's been building here, I've got it's already started building a simulation of the entire Toyota system on my neural graph system. So that's it. All you need to do is ask it, and you can get going. Just having the right tools is the key part of the story here. All right, let's. I think I'm. Oh, I skipped one slide. I'm just going to give you one last slide because I want to give this one. Um, Vibe coding versus agentic engineering. That's the final question. And if you're going to become an agentic engineer, you're going to be forced to answer this question frequently. And some people, don't get it, but those who do get it will see it quickly. So agentic engineering and vibe coding are different ends of the spectrum. Vibe coding is fluid, it flows, it has little process. The human is the feedback loop. You are sort of guiding it, but you don't even know necessarily what the right answer is. It's about discovery. It's about ideation. It's about learning. It's about seeing and seeing and understanding the things you didn't know. Agentic engineering is about applying all those things that you learned, applying it to create process, applying it to do deep planning and test-driven development to create something you truly do understand, or at least understand better than everybody else. And that's the key here. Understanding that there's a spectrum between the two. And I think I think I'm out of time.
You're doing fine.
Is that it, guys?
Yeah, it's good. It's good. Yeah,
Oh,
we could move on to the global chapter session, unless you have
yeah.
other things to show.
Unless, well, you guys know me. How we do for time? I can show lots of stuff. I've got an infinite supply of show and tell. I think I was born for that. I've got Claude Flow, which might be interesting for folks as well. Um,
Um,
let's.
what I'm thinking is if you can show one of your agents, like you do it on the fly, and we're gonna go ahead and do the global chapter and education, and come back, and if you can show the agent, that will be great in like next 20 minutes ish.
All right. Okay. Let me stop sharing.
All right, thanks.
And thanks everyone for. I hope I didn't go too fast. I know I speak fast. But I appreciate everyone coming here today. Thank you.
Yeah. Okay. Uh, Next, we're gonna. Okay. Um, Next, we're gonna introduce you our chapters globally. Uh, yeah, I forgot to introduce myself. I'm Robert Ye, and I'm the chair for global chapters, working together with the other Robert. Oh, here. So Robert and Robert, and we are, because I'm mostly in Hong Kong, sometimes Shanghai or Singapore, and Robert Ranson is in Toronto. So we're roughly 12 hours apart. So perfect to cover globe. um, and we have, yeah, Rob, go ahead and, do you want me to go through this? Because we have the slides loaded up. You want to do it from here?
Your preference, I can share right here. I've got this one pulled up, Robert.
Okay, why don't you go ahead and share your
Okay,
slides? Yeah.
sure. Let me one moment,
Please
and I
do share these
will
slides.
do it like this.
We should
And
stop.
like this. Share and slideshow. Right. Can we all see that one now?
1 second. We're we're gonna switch the screen. That's our screen, right? Stop our sharing. It's already is okay. All right. So Rob, go ahead.
Yep. Okay, very good. So this is, yep. Okay, excellent. Hello, everyone. It's a pleasure, and thank you for having me, and I'm very pleased and excited to be able to share this with you. And thank you, Robert. It's been a wonderful year working together with you in order to help establish the spirit and the structure of the chapters around the world.
Likewise, likewise. It's my shadow talking. So go ahead.
Very good. And as always, Ruben, thank you. The leadership and the innovation that you bring to agentic engineering is remarkable and celebrated. So it's always remarkable to see. The community has come up over the last is 15 years of machine learning, and has brought some remarkable AI products to market over the last decade, and they were just they have been remarkable in their leadership of the France chapter. In fact, Jean-Marie was the panelist at the Adopt AI event in Paris just last week. And so he was hosting the panel with industrialists such as Siemens and Renault Group, Salonia, and the like, around the conversations about industrial twinning in order to understand how they may be able to both model those industrial systems in order to optimize them for sustainable energy use and a host of other benefits. So it's been wonderful to see that kind of leadership out of chapters in first in London, of course, Vensa and Mondweep. The first event was hosted at Google and now by 42. Again, thank you. It's a wonderful partnership that's flourishing around the world. And this is the entire crew. That's actually a big team leading the London chapter, but they host and speak on security issues, and agentic design elements as far as user experience. and are doing a lot of work in healthcare as well, bringing the technology to the healthcare industry. And then, of course, we have our Toronto Tech Week. That's the very front. It was actually a very big room. And in Malaysia, that's our very own Robert E. there with Tommy Lima. And that was at Malaysia at the APA Summit just in September.
Tommy
So,
is the one to my left.
yes, yes, that's right. That's Tommy there. Yes. And New York, chapter in New York City, right in the heart of Manhattan, is wonderful. Of course, New Zealand. We can never forget our Kiwi friends, and led by Chris Barlow and Mark Vincent and Dr. Simon now as well. And they're remarkable engineers. They also work closely with the New Zealand government and have enabled the adoption, the approval of Cloudflow and other engineering frameworks, agentic engineering frameworks, into the environment of the development environment of the New Zealand government. So they're doing remarkable work. And then, of course, many, many more. Again, we can't touch on all of them, but we did want to give you a sense of the breadth of the community. And as the acceleration of engineering continues, we find and feel that it is important that our role is to help the rest of leadership and the rest of the organization also prepare for the impacts of accelerated engineering. And so that has to come at the local level where professionals, engineers, and students can come together to get their hands on the technology and really understand what it's about. So, and that's the little session on our chapters. Thank you.
Thank you, Rob.
My pleasure.
Thank you, thank you. Thank you so much to my shadow. We're going to move on to next one, which is Agentics Academy. Education has been a key initiative within the foundation. For that, we've been building up programs led by Brad and Nick. So Brad and Nick both are online, and you want to take it over?
Sure, thanks, Robert. I'll just share my screen here.
All right.
Can you see my slide?
Yes.
Okay, great. Thanks. So we see all these great things happening, all these great things being built, but you got to get started somewhere too, right? And this is what this education program is all about. It's just, you have to get from, you see Reuven creating like all these amazing agents and all these amazing solutions and people are using them. But sometimes I get this question a lot, like, I really know this is important and I really want to get involved, but where do I start? You know? And that's where the Agentics Academy comes into place. So we created a certification that's a little bit more theoretical, and you'll get the key concepts and the core mental models of agentic engineering. You'll learn a little bit about the idea of supervising agents, writing effective specifications, which is how we have these systems build solutions. And we more recently are rolling out the Agentics 101, which is going to be, going to take anywhere from a few hours for someone that maybe has some experience to maybe 10 hours for someone that is completely brand new. But in around 5-6 hours, and that includes the learning modules as well as the actual implementation. And what's really exciting about the Agentics 101 program is that you're actually doing something, right? You're actually going to go into GitHub, you're going to make a repo, you're going to make your first agent, it's going to do something, and you're going to go through a process of actually, as opposed to just learning about specifications, you're going to make a specification. You're going to improve upon that specification. You're going to learn a bit about architecture, but then you're actually going to do it. you're gonna look at something you built during this process, and you're gonna see like maybe I want to. Maybe something here is not working properly. I want to fix this, or maybe the color's not right, or maybe the AI went off into left field on you, and you want to get it back under control. So you're gonna go through a number of these processes in this course, and when you come out the other side, you're actually going to be prepared to show an employer that you have a working knowledge of not only the language of agentic engineering, but how to actually do some of it. And safety is a big part of this as well. You know, how to use these systems responsibly, and you become more of a supervisor as opposed to a prompt writer. And the great news about this is it's actually open and free for all 42 students. So, as a part of the 42 partnership, you're actually able to access these courses, both the certification and the Agentics 101, at no cost. So it's a great thing. It's a great partnership that we're developing together, and we're really excited for it, obviously. And there's events popping up all over the world because we have the support from 42. So it's really great to see. And by taking these courses, you're effectively, we talked about the live events like the one you're at tonight, and becoming part of this community. I've been a part of a lot of different things over the years, but nothing like this. Like the people are so great and the support is incredible. Like starting from, I always believe that the way the leadership behaves and acts, it just reflects all the way through to the rest of the organization. And we got this guy Reuven, he could gatekeep everything he does. He could keep everything from everyone and just keep it all for himself. Instead, he gives everything away, and anyone can use his stuff. And he's extremely generous. And I feel like, everyone else, inevitably follows along because it's like, well, if Reuven's giving all his stuff away, well, I better do my best to support my neighbor in the foundation. And that is really ingrained in our DNA. And I really do believe that separates us sort of from the general way things are done and things like that. So, as I mentioned, you're going to get into the agent supervisor mindset as opposed to a handwriting code or a prompt writer. You're going to actually understand how to control and constrain and direct AI systems more like an engineer, not like someone that's kind of hammering on a keyboard in ChatGPT. And it's not to say that's not valuable, because it is. You'll learn a heck of a lot from these like LLM chat tools, but we're taking you much beyond that environment into an actual world that separates you from the average AI user into this world of agentics and agentic engineering. And you're going to actually build a multi-file prototype, multi-agent projects. You're going to in the agentic 101, you'll actually build more than one agent by the end. Or even more if you're really motivated. So it's a wonderful opportunity to really digest some of these concepts slowly without feeling overwhelmed. And this stuff can be very overwhelming at times. And this course is really great for anyone new or even someone that is a programmer that is doing things in a conventional way would still get a lot of value out of this course. Perhaps they might just go through it a little bit faster. And we also have a secondary track which is a little bit more advanced that that includes some of the code spaces environments, and you can use VS Code. Maybe you could use this the Cloud Code Web that you're seeing Reuven demo tonight. So there's something in it for everyone. It's really useful, and it really shows, as I mentioned, an employer will be able to see your progress, and it's all documented nicely by the end, and they can actually see what it is you did, and you'll be able to very coherently explain to a potential employer, like, this is what I did. I built a profile card. I built a landing page with a functioning button and a functioning mail to email button and a click to call button that actually works, and the stuff is great. And this is how I iterated through the process from prototype to something that's a little more polished and things. So it's your pathway into advanced agentics learning. You know, it's all starts with one step, and this is a great starting point for anyone to break in. And the tools are getting better every day. You know, your ability is you know, all you got to do is kind of follow some of the folks in the organization, see what they're doing, and just do your version of that. You know, and you'll it'll take you really far. Like if you start to learn some of the foundational sort of ways in which these things are being built through this education program, like you can do something like what Reuven was just showing. You could just use something that he's built that's extremely powerful, and you can build whatever you want. So, you know, it just takes a little bit of commitment, getting a little bit out of that comfort zone with some of this education material. And we'll be releasing, you know, 201 and 301 and 401 as we move forward. So there will be stepping stones for you to continue that educational path with us. But with that, I will pass it along to Brad Ross.
Oh, thank you, Nick. Nick, if you could just continue
Sure.
going through the slides, appreciate that. Hi, everyone. Thank you very much. Thank you, Robert. Really appreciate being here today with everyone. Uh, just very quickly want to explain, this is our global launch for Agentics 101 as well. So we're really excited that it's at this venue to be able to have it. It's been an amazing process. It's been a global process, working with teams all around the world, different professors, working with Reuven, the team that you have here from Toronto, Robert Yee, all the people that you saw that were involved in different chapters. We all came together really for this course, and really brainstorming about what is it and how do we get people to get started. Because what you see Reuven being able to do is truly magic. Even though I know a little bit about how it's done, it's still magic to me. And what this course really is how do you learn what the magic actually is behind the scenes? So it's we go through, and as Nick mentioned, it's a step-by-step process that you can do. If you can go to the next slide, Nick, we can show a little bit. But it's really a step-by-step process to understand how do you get involved in this world of agentic engineering? How do you go from just at the very start, making sure that you have some systems set up? The course has been designed where everything is free. You can use completely free tools, so absolutely no cost. You start out with working with your chat GPTs or other chat bots and get your feet wet and understand how do you actually understand what an agent is and how do you create your first agent. And we go step by step, and all the way through the process, you're actually building and understanding. And by the end of this course, hopefully you have a fundamental knowledge. And what I mean by fundamental knowledge is you've gone through and you understand how everything works, and you've actually fingers on keyboard and actually been able to build something. So when you start looking at what Rube's doing and what Robert's doing and what the rest of the team is doing, you understand, oh, they're creating an agent that does this. Well, I remember I built that before. I understand how they're doing it. Now I can take a little bit of what they're doing and add a little bit of what I'm doing and build my own things. So we're really excited about this. There's a QR code available on the right-hand side, and our community address. This course is open up and it's completely free for everyone. All the tools are completely free. There's videos involved. There's step-by-step processes, and I do encourage you, if you would like to go through this course. As Nick mentioned, it's about 6 hours, so it's not easy. You will get a lot of experience though, and we're really excited about it. And I just like to thank everyone that helped out put this course together, and I hope you guys enjoy it. Thank you.
Yeah, let me just add to it. You know why it's not easy? Because Brad is a teaching fellow at Harvard, so it's not easy. uh, but seriously, in between Ruve, Nick, and Brad, there's a very strong education background. They're all associated with, Brad with Harvard, and Ruve is with University of Toronto, and Nick is also teaching there. So there are certain courses they teach. This is why education is one of the key initiatives within the foundation. And we do hope to work with Anthony to start this in Japan and hopefully expanding to other parts of the region and of course, to Europe and other parts. Um, so thank you very much. Ruth, are you still there?
Yeah, yes, I am. Hey,
Wow, wonderful.
so
Let's
awake,
come back to
so
you.
awake.
You
Yeah,
ready to go or
it
yeah?
I've been building, I've been trying different things here. Let's see what we have here.
All right.
So I let's recap where we left off earlier. Hopefully I can share my screen here. So we're like let's simulate an entire company and see what we can do. So I said let's include every employee, every supplier to the company, everything that it touches. Let's create a simulation of that. And so then the system looked at my various components. It created a plan, and it created some code to sort of explore my application. So you can see here that it created this in TypeScript, which is cool. I like TypeScript. I use a combination of Rust and TypeScript. So I build my core logic and AI in Rust, and I compile that either through a WASM, which sits in your browser and can be easily used on different environments like a phone, or I use a compiled version, which gives me the ability to use the AI inside of TypeScript or JavaScript, and that's what makes it really powerful. So what you're seeing here is that this is the parts that sit in between building all that because it knows my libraries and knows how I like to build. So you can see here we've got different departments that it's created, which is kind of cool. We've got executive board, we got the Toyota Motor Corporation, we have Lexus, Gazoo Racing. Don't know what that is, but I'm sure you probably do. Assurance, yeah. So and we have different brands. Hino Motors, which I think I've seen Daihatsu. So interesting. It's creating the structure. We'll keep going. Let's see what else it's got here. It's building different kinds of components. This is the agent. So it's built an agent. So the agent is the simulation, right? The agent acts like a role. It could be the CEO, or it could be a robot in the factory. It could be a phone. It could be anything that is involved in the business, and it simulates that. So you can see here the different structures: agent state, department, skill, relationships. That forms a graph, an interconnected graph of all the parts of the organization that the system needs to understand and operate against. So the system, because I gave it my tools, it kind of just knew how to do this, which is the coolest part. So it's doing all kinds of different things. I won't spend too much time on it. So let's keep going. Right, I'll keep scrolling. And then we've got a organizational structure, different vehicles and things like that. We've got supply chain, different suppliers. We've got the manufacturing simulation. It'll create a robotic simulation on the fly. It creates a world model that understands how this particular company exists within this model of its world that it lives within degrees of separation of people that it works for it or people who supply it, that kind of thing. And the simulation engine. This creates the simulation. And let's look at that. This might be interesting. This can be really useful for games, by the way. The simulation creates, again, a world simulation, and you can do really, really fine-tuned global simulations. I could simulate every person in Japan 1,000 times a minute forever. Understanding, looking, adapting, trying to make your life better for healthcare. Imagine an AI that knows all about the things that are important for your particular body, your DNA, and having that understand that really quickly for everybody. That's what these types of agents can do. They understand and they're able to operate. In this case, it's for looking at a motor company. But we'll keep going here. It's creating a simulation. So it's using my library. This is basically glue. It sort of brings it all together. And we've got it's testing the seal. Oh, look! It even made a little logo. That's Toyota Self-Learning Enterprise Simulator, powered by Rue Vector. Right? It does that sort of thing. You saw, I told it basically really broadly that but it created a self-learning and like this has never been done before. And we can run different simulations by running suppliers, and these are commands you could pass it. It's got different options for that. And then to run it, let's keep going. So built a little built a white. So we can actually now, if I want to try this, we can go here. I can click the create PR button, and this will take me to the website. And now I can see the MCP or not sorry the GitHub for it. So you see it wants me to create a PR. I don't want to create a PR, but I do want to take a look at what it built. So I'm going to go back here, and now I can see my different if you're looking for all the crazy things I'm building, you want to check out my Vibecast GitHub. But in this particular case, I've got 56 branches of all kinds of crazy things. But we're looking in this case for the Toyota simulation. So we're going to go here, and here we go. We have a sort of overview page, the Toyota Motor Company self-learning simulation, a comprehensive self-learning AI agent system that simulates the entire Toyota Motor Company, including 370,000 employees, supply chain partners, and manufacturing operations. It does it globally. It created 19 product lines. So this is how you install it. You can run different simulations. And this works super fast. Like in terms of you could do these simulations. You can do, I think we saw a stat the other day of 3.2 trillion simulations in 1 second. In 1 second. So think about how many things you can look at if you can do 3 trillion simulations of little tiny parts of a bigger piece in that time. All right, so now we got some code. Looks like it created simulation code. Let's take a look what that looks like. Simulation engine. This is the Roov code integration. Here the agent. Here's the Toyota stuff. Toyota stuff looks kind of interesting. Now, not a lot here, so we can go back and we can go to the bottom and we can say run deep benchmark and simulation 10,000 times. So we're simulating 370,000 employees, all their connected, relationships, business suppliers, everything that makes either cost the company or makes the company money. And we're looking at all those things. And we're going to simulate it. And I just did it just to show you guys that it's possible. All right, so run deep benchmark and simulation 1,000 times and save report to the /reports folder as MB files. Use ultra think. There we go. And now it's going to take that even further and now I'm building on this and I'm building on that, and I can do that for anything I want to simulate. I can simulate literally, if you can imagine it, planets in the sky. If I can look at the Kuiper Belt and try to find anomalies for meteors that might eventually hit the planet Earth. I can look at cancer and can do correlation between the bacteria that sits in your stomach and your DNA and the likelihood of a completely personalized medicine. It's all a simulation. And these simulations are the basis of the agent. Yeah, we're watching it do its thing. It's kind of one way. I don't know if you guys have any questions, or we're happy to answer things too. A little more interactive if you want. Rob, you there?
All right. Sorry. Thank you so much. I know it's really late for you guys. Perhaps any questions at all for Roov, our Toronto team? Any questions at all? Yes. Okay, we have one question here.
Oh no. Okay. I'm really interested in the foundation, and how can I'm just curious, how can we integrate or how can we learn the agentic stuff here as a 42 Tokyo student? Yeah.
I will answer that question. What we show you the Agentics 101 and the certification program. That's the place to start with. That's the very purpose we build those programs. I mean, you can try the certification program first and see where you are, if you pass or not. But you can also register for Agentics 101. It's not easy in the sense that you have to understand programming, the basics. Otherwise, if you do you have a GitHub account, by the way? Okay, good. You're the right one. Yes. By all means, try that. And as Nick and Brad mentioned, it's going to be a full-blown Agentics program we build. So you can take 101, then gradually move to 200 levels, 300 level. And if you have a major project going on, for instance, working with Toyota, if you have the opportunity or with a research institute, you need really advanced AI support. Anybody you see here from Roof could be your mentor, could be your partner in those projects. One thing you probably we didn't mention that much is that in between the founders, the key people within the foundation, there are some of the world's largest AI projects, right, Roof, that we've been working on. In Asia, there are a whole bunch of AI projects on the financial industry, banking, insurance, security, brokerage, because their internal process is such that it's very complicated, it's highly repeatable. Sometimes there are different rules. Before this, there's an industry called RPA. Not sure if you understand RPA, robotic process automation. So what AI brings to us is that AI brings a new way of creating the rules. Because for RPA, there are two key elements. Number one is highly repeatable. Number two is rules driven. Okay? So before 2016, in RPA, all the rules are pretty much based on human knowledge. Like you're working for a customer, let's say it's a huge insurance company. That company has one guy who's been there for the past 10 years. He knows every single step, every single thing, okay? So you actually go to him and say, what are the rules or the steps that's been working for you in the past 10 years? He's going to tell you 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So you write a script, you follow this, you let the machine run. But now with AI may come and tell you, no, it's not 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's maybe 1, 2, 3, 7, 8, 9, 10, right? Because the rules are different. Because AI is much more capable than human in terms of cracking data, finding out a pattern, and they do it so much faster, right? So this is only the basics on this, right? Again, any questions? It's getting really late. It's like 1 a.m. now for our Toronto team. Yes, please. Hey, Professor, good to see you.
Hi, Ruth. Thank you for the live session. Quite interesting. My name is Antawip. So I have been playing around with Agentic AI and some of the tools that you have been talking in the live sessions as well. It's very good for me to prototype some rapid ideas or for research. But recently I tried to implement a production level mobile application. And the difficulty that I faced was that I don't know what's going on if the system is complicated. So from a production point of view, when you deploy for production, there are issues that creep up. And if I try to fix one issue, there are 10 different new issues, unknown issues that will come forward. So from a production point of view, how do you see is this being addressed? Thank you.
You're describing the vibe coder's dilemma. You doing 95% of the work is easy. The last 5% is 95% of the effort. And that is the key to software in general. Now, what you're describing is I can create an idea, I can visualize it to a point where it sort of works enough to show, but taking it and making it something that I can sell and won't be hacked, won't lose my customers' information, will scale, and when I get a lot of visitors and all the things that are actually hard about an application, that requires you to understand how applications are built, how they're architected, how they scale. And that's the difference between a vibe coder and an engineer. An engineer knows how to guide the system through the complicated parts that someone that's more novice may not know or to even ask, right? So it's mostly knowing what to ask and being capable of learning. So the real answer is you have to, like anything, you have to practice, and you have to learn the things that are going to allow you to get to a final state that you're happy with. And that's not going to happen overnight. I was, before I started, being an agentic engineer or vibe coder, I had been programming since I was 8 years old. That gives me a substantial advantage in knowing the questions to ask, and that allows me to go beyond what I'm capable of knowing, because I know enough to be dangerous. Yeah, I think
Right.
that's it from yeah.
Uh, Nick, I saw you knocking your head. You have
Yeah,
anything
I was
to
just
add?
gonna say if you're running into those sorts of situations, it means you're on the right track. Like you're just going through growing pains, and this is all part of the process. Like if you're not experiencing this, you're probably not trying hard enough. So kudos to you for taking it this far and getting to this point of growth that you're in. That this is a big step for you to you know just keep paying attention to what the AI is doing and maybe get a little better at specification writing and get a little better at architecture and just keep going. Like you might build another 10 things that you run into the same wall that you're at right now, but then that wall will start to come down. You may not get to the Reuven level of building something in an hour that might take someone else. It might take you a month to build what could take Reuven an hour to build, or 10 minutes or something. But you could still do it. But it takes these courageous acts of failure, persistent failure, basically, to get to something that's working. Yeah.
Thank you, Nick. All right. For our Toronto team, we're gonna take a break. So if you guys need to go get in bed, please go ahead. Thank you so much for staying up late.
Our pleasure, and thank you for coming out and all the work you did, Robert.
I hope you guys can hear all the you know clapping here. Very much appreciated.
Yeah, you got to come to Canada again soon. It was great seeing you last, earlier in the summer.
Oh, absolutely. Yeah, one thing I will mention is that I wasn't joking about Rue being half Japanese. I've been trying to bring him back to Tokyo, but this time I couldn't make it happen. But sometime next year, I hope early in the year, we're gonna
My
have another event here, and I'll bring Rue and hopefully some other of our leadership team over to Tokyo.
and just by the way, my wife grew up in Tokyo. She lived in Tokyo for 14 years. She went to the A Side J, she called it high school, which I think is American high school in Japan. So very close ties to Japan. So yeah, I think she grew up in the Roppongi area. So if you know that area.
Now you know.
Yeah, that's my Japanese side. It's not. It's sort of. It's sort of kind of. There you go. Through marriage.
Yeah. Again, thank you so much, Ruth, Nick, Rob, Brad.
Thank you.
All right. Till next time.
Have a great night.
Take care.
For us, we're gonna take a quick 5-minute break. After we come back, we're gonna introduce to you Professor Toshiya Jitsudumi, Mr. Ida, um, right here, and one of the key topic for us is actually connecting policy, technology, talents, and businesses. So all the key elements somehow needs to be connected to make sense. Because we're a human, we're complicated. Right? So 5 minutes after we come back, we're gonna have Professor Toshiya and Mr. Ida on the stage. Thank you. And Mr. Yoichi Ida has been a speaker representing Japanese government, Ministry of Internal Affairs and Communication, G7, G20, those worldwide stages. Okay, and Professor Toshiya went to Columbia. He's a law professor and policy researcher at Chuo University. Okay. All right. So without further ado, please.
Can I have a slide?
Okay, so good afternoon. My name is Yoichi Ida, as kindly introduced, and I have been working for the government for maybe over 30 years, representing the government in multilateral forums such as G7, G20, and OECD. And the recent experience was the negotiation over the Hiroshima AI process, which provides the governance framework for advanced AI, including the generative AI. We negotiated the framework 2 years ago. So I'm sharing my experience. And I was expecting, Professor is supposed to talk about the third way of Japanese policy making, which I was thinking of to follow, but let me start with my own presentation. So actually, I'm using the regular deck, and which takes normally 40 minutes or so, but I will try to make it shorter today. So I will skip some of the slides, but you can have a look at the details after the session. By the way, I was very much impressed with the introduction of the foundation and also the courses. I want to extend my congratulations to the grateful, very great launch of the Tokyo chapter, and also I was very much interested in the courses which is provided by the professors, and I was thinking of how I can join the courses after this session. Maybe I will learn more, but let me start my presentation. So the Japanese government, normally, the policymakers are very slow and also, very conservative, and always try to regulate everything. But this time we were a little bit different. So in AI policymaking, we were very active for over the last decades, starting in 2016, when we started the discussion on AI guidelines in Japanese community. So at the time, we had the minister of Takaichi as our minister, and in our ministry, and we started the discussion on AI guidelines for research and development. At that time, we saw a lot of, impacts, a lot of benefits, potential benefits, but at the same time, a lot of risks and the challenges coming up from the new technology. And there was a big argument between government and the industry at the time. So the discussion was, how much we should regulate, how we could regulate, and whether we should regulate it or not. And then the final conclusion as the whole Japanese community is, we shouldn't give the excessive regulation over this technology because there are two reasons. One is, as you know, Japan is the super aging society, and we are lacking the labor forces. So we need to make full use of the technology in our economy and the society. At the same time, as you know, Japanese people, Japanese businesses are very cautious. So once we regulate the technologies, the people are very much reluctant to use it or even develop it. So we decided to put a guardrail around the technology to avoid excessive regulation on the industry and the technology itself. So the approach was the soft law guideline. And now it is now the managed between our ministry and the Ministry of Economy and Industry jointly. But in 2016, we started the discussion on possible guidelines on AI technology. At that time, we were talking about traditional AI, such as machine learning or deep learning, and because the generative AI was not there. And we were very bold because we started the discussion in 2016, but we also proposed the international discussion over the guideline in G7 in the same year in parallel. And the first reactions from my colleagues in US, UK, Canada, France, those governments were very much reluctant because they said they know internet, they know telecommunications, but they don't know about AI, and AI is computer thing. We know the network and we know the internet or communication, but AI must be different. But our way of thinking is, AI will work interactively over the across the borders, and we need a kind of international collaboration or coherence in governance frameworks. So we started the discussion in 2016, and we continued the discussion in G7 and also in OECD. So these efforts were sometimes materialized as OECD AI principles in year 2019, and which was also reflected in G20 AI principles in Osaka summit in the same year. And these efforts paved the a kind of robust common understanding across the countries when we faced with the new challenges coming up from the generative AI in the late 2022. So this is just a set of the very early draft of AI guidelines, which was presented to G7 in 2016. And you may see a lot of similarities with the OECD AI principles, which was agreed across government in 2019. But these things are all talking about traditional AI. And these OECD AI principles were updated last year, reflecting the new elements coming up from generative AI. But at this moment, this was the governance supposed to be a governance framework for traditional AI. So after these efforts, we came to the rapid emergence of generative AI late 2022. As many of you remember, near the end of 2022, ChatGPT 3.5 came up, and we started the discussion in G7 early 2023, and in May in the same year, the leaders agreed on launching the efforts called Hiroshima AI process, which was supposed to discuss and agree on the governance framework for generative AI and the other advanced AI systems. But at that moment, nobody was thinking about agentic AI yet. So through the year, we continued the negotiations. Normally, when G7 gather online, we start 8 o'clock or 9 o'clock in the evening in Japanese time because of the time difference. And then we continued, sometimes we continued until 1 o'clock in the morning, 3 o'clock in the morning, and sometimes 5 o'clock in the morning. And these negotiations continued for 3-4 months. But before the end of the year, we agreed on the comprehensive policy framework. You may hear sometimes the name of comprehensive framework of Hiroshima process, but you don't need to care about it because the core elements are just two instruments, which are guiding principles and the code of conduct. And guiding principles is the set of 12 items which are providing high level but action-based principles for all AI actors in AI ecosystem. And let me briefly touch upon this later. But the other element is called code of conduct, and which is addressed to AI developers. And the code of conduct provides some specific recommendations for actions and measures to be taken by AI developers when they develop advanced AI models or systems. And let me go through quickly the individual elements. The first two elements of guiding principles are talking about risk evaluation, risk identification, and risk countermeasures. So these two elements are requesting all AI players, but in particular AI developers and the AI deployers, to evaluate, identify the potential risks in their models and the systems, and take the appropriate countermeasures. The second set of 3 items are talking about information sharing and the disclosure. So once they understand the possible potential risks in their AI models and systems, they should not hide this, but they should share the information with other stakeholders. And even when they see some incidents happening from their AI models and the systems, they need to share the information with other stakeholders so that the community can collaboratively respond to incident after in later on. So this information sharing and the disclosure is a very important part of code of conduct. And the next items are talking about some technological solutions to tackle some special particular risks and the challenges coming up from generative AI, because when we analyzed what are new for generative AI apart from the traditional AI models, lack of transparency or some cybersecurity risks were the some part of the focuses. So these three items are advising AI developers and deployers to take appropriate measures such as watermarking or some other technical solutions to help users understand they are using AI and the content or products are generated by AI models or systems. And the last so last part is talking about more general things, but you may please have a look at the details afterwards. But let me mention last item number 12. This is talking about the trustworthy and responsible use of advanced AI systems, and the more specifically, this is advising the users and the also other stakeholders to work together to improve the literacy, AI literacy of users, so that the users can appropriately use the AI models and the systems in their daily lives or economic activities. So our way of thinking is even end users or other business users are responsible for AI security and safety, not limited to developers and the deployers. And the next 2 pages are showing the more specific recommendations presented by Code of Conduct, but please have a look at these details after the presentation. So these Hiroshima process frameworks are providing the governance framework, which is very voluntary, and for example, the companies can announce they are fulfilling all 11 items or all 12 items of code of conduct, but there is no evidence and there is no way to verify this. So we G7 successfully discussed the monitoring mechanism, and the discussion reached to the conclusion of reporting framework, because there is no concept of for the government to monitor the voluntary actions by a business or other players in a voluntary framework. But the idea is the all AI actors make report on voluntary basis. So we expect the companies and the other organizations who follow all 11 items in code of conduct should report and share the information publicly on what they are doing and how much they are doing. And this reporting framework provides a questionnaire to help those companies and organizations easily share their information by following the kind of specific questions in questionnaire. So the questionnaire provides 7 questions which are following the 11 items of code of conduct. So they are asking risk assessment and risk management and safety and security measures and blah blah. So by following and answering these questions, companies and organizations can effectively share the relevant information with other stakeholders. And at this moment, 24 companies and other stakeholders, organizations have submitted their reports, and these reports are fully uploaded, publicized on the OECD website. So you will see some big names from the US industry. The blue colors are showing the US companies, and the red colors are showing Japanese companies, and the black colors are showing the companies and organizations from other jurisdictions. So as you see, you know, the more than 60–70% are US or Japanese companies. So we are now encouraging the European and the other governments to encourage their companies and organizations to join and do this exercise to share their governance exercises with the public. So the idea is, we government shouldn't the some top-down regulation over this technology, which can be always, I shouldn't say always, but more than often, excessive, because from the policymakers' perspective, the biggest difficulty is AI is changing so quickly. So before we understand, things are changing, and I think the EU AI Act is the good example. They are already struggling, how they can manage their new legislation to adapt to the new situation. And they, of course, they don't want to, hinder their innovation. And before the EU AI Act was enacted, my colleagues from European Commission were always saying, their AI Act will not be hindering the innovation, but they are promoting the innovation. But in the end, the result is very difficult. So I think, the voluntary mechanism should be appropriate here. And we encourage voluntary actions and measures taken by, companies and organizations. And we also encourage voluntary information sharing and disclosure. So this is what we have done. And ideally, users and other stakeholders can see and understand what they are doing and how much they have risks and how much they have their models and systems are safe. And then the market and the users, or even the investors, business partners, and the government and the authorities can give more greater trust to their AI models and the systems. So that the good cycle, if this good cycle works, there is no need for top-down regulation. But it is still difficult to complete this cycle. And currently, I see maybe 3 major problems. So one is, it is often difficult to fulfill the questionnaire which I showed in the previous slides. So in particular, small companies do not have enough capacity to follow all these things and try to make their responses to the questions. So we are now giving a lot of efforts to simplify and streamline and help the companies and organizations to join and participate, fulfill the questionnaire, and publicize their information on the website. This is one thing. And the second thing is, if you visit the OECD website and try to have a look at the individual reports by companies, if you look at the OpenAI's reports, you see 30 pages. If you see maybe Japanese companies, they give 10 pages or 20 pages. But if you see Microsoft, they give 60 pages. So, of course, detailed reports are very valuable, but it's often very difficult for users to read up and understand everything. So there is a lot of difficulty to, make full use of these reports. And there should be some work for the government to help users to easily understand and make use of this result into their work, business, or whatever. And the last one, it must be the most difficult one. There is no incentive for the companies and the organizations to join this framework. So as I said in my previous slide, there is no feedback from the market or other stakeholders to companies. So after publicized their reports, they did a lot of work, elaborating 60 pages, and then they publicized their report on the website, and there is just a few reactions, Okay, this is good, that's good efforts, but they don't see any increase of for example, the usage of their AI model. So there should be some feedbacks from the market or users or even other stakeholders, government, for their efforts by the companies and organizations. So this is the most difficult part of this mechanism, but we are tackling this as government and also collectively as not only as G7 but as OECD too. And this is one of our efforts. We are running a group called Hiroshima Process Friends Group, which is now a group of 60 governments and the region, and mainly from developing world. So you see the member countries, and we also have this Friends Group is a group of government, but when we discuss AI policy or AI business, AI application, whatever, we need business partners. So we have a partners community inside Friends Group, and there is the now 30 organizations joining us to work and help government to understand, to work collectively and probably govern appropriately AI systems. And these are the names of the companies and organizations. And this community is a little bit different from the community of Agentic Foundation, but there should be a lot of commonalities, or there should be common objectives, or I hope there can be a lot of complementarity in the future. So this is the current position we have reached, but there is a lot to do in front of us. And as I said in my last slide, we always need to work together across different stakeholders, from government to business or civil society. So I think today's session is one of the good opportunities for us to work together. And I look forward to the collaboration. Thank you very much for the time.
Thank you very much. Arigato. Thank you, Mr. Ida. We're going to have Professor Toshiya. Okay.
Thank you, Ida-san. Actually, he forgot to say something about me because I'm 2 years senior to him. But we born in the same year. He spent extra 2 years at the university. That's why he's junior to me, and he accepted my offer to come here to make some presentation. He is the most important person in Japan, the Japanese government, to talk about AI governance and the policy, because he maybe 5 years in chairmanship in the OECD, for 6 years. 6 years in chairmanship of OECD committee talking about governance and policy. And Mr. Ida is very famous in the global discussion about AI, so that it's very prestigious for me, and I think for the Agentic Foundation, to have him as a keynote speaker here. Okay. All right. Okay. So good afternoon, and thank you very much for the opportunity to speak today. My name is Toshiya Jitsumi from Kyoto University in Tokyo. Unfortunately, I'm not a programmer, not an engineer, so I'm just a humble professor of economics at the Faculty of Policy Studies here in Tokyo. So in the world of AI, I might, what you might call a second-class citizen, but
I try to be as friendly as possible to this new technology AI in preparation for the possibility beyond the singularity where AI dominates humanity. So okay, before moving into academia, I spent more than 18 years at the Japan Ministry of Internal Affairs and Communication, or MIC, where I worked mainly on the telecom and internet policies. My recent research is that focused on the issues related to telecom and internet policies, AI governance, and platform regulation and AI policies. So today, I would like to talk about the trust and AI governance and how they matter for the future of agentic AI or the artificial intelligence in general. My core message is very simple. If we want agentic AI to move beyond the trap of disillusionment, we must treat governance and transparency not as a brakes on innovation, but as an infrastructure of trust. Thomas Carlyle, a prominent 19th century Scottish essayist, historian, and philosopher, once called economics a dismal science because economists tend to talk about constraints, trade-offs, and unpleasant realities. This image of gloomy discipline may not sound very suitable for an event when we celebrate the beginning of Tokyo chapters, or maybe perfect match for a bit cold and cloudy day like today. But in any case, as a modest member of dismal science, I would still like to begin by looking at the realities. Of course, not to discourage you, but to be honest about the limits, risks, and trade-offs of AI and agentic AIs. The question I have right now is the current AI boom a bubble or something more durable? On the last 2 years, we have seen an enormous AI hype. Investors, media, and policymakers have often talked about AI as if it could solve everything. But at the same time, we are beginning to hear the different tones these days, such as, is this an AI bubble, or is the hype already cooling off? We see concerns about over-promising, hallucinations, copyright issues, safety, and ethics. But my view is that this pattern is not unique to AI or agentic AIs. It is a part of a more general cycle of hype and disappointment, which is nicely captured by the Gartner hype cycle like this one. You can find an AI agent at the top of this curve. In this framework, the trough of disillusionment is almost inevitable. That is, after a period of inflated expectation, reality sets in, and reality sets in for every one of new technology we can think of. But what is not inevitable is a failure. Some technologies never leave the trough, but others could climb the slope of enlightenment, find realistic use cases, and become part of everyday life. So the key question for us is, will agentic AI stay as a bubble or become a mature, trusted infrastructure in the future? I will argue that the governance and the trust are crucial piece in determining which path we are going to take from here. To discuss agentic AI, we first need a basic distinction between AI and agentic AI and AI agent. On this slide, I use a simple working definition. An AI agent is a software system that perceives physical and virtual environment, pursues explicit or implicit objectives, and produce output with some degrees of autonomy and adaptiveness. Actually, the agentness in the AI technology had long been discussed by the engineers for more than 10, 20 or 30 years. On the other hand, the new breed of AI technology that is the agentic AI goes a step further than the AI agent itself. Agentic AI is a system with a heightened autonomy and a goal-directed behavior. In practice, it can do at least 4 things. First, it can plan multi-step tasks. Second, it can break down goals into sub-goals. Third, it can call tools and APIs. And finally, it can operate with limited human oversight. In that sense, we are moving from AI as a tool that requires direct human control and attention to a new AI as an actor that can coordinate many tools and actions for our behalf without a human intervention. This shift has a very important implication for responsibility risks, and AI governance. Acharya and colleagues describe agentic AI as a qualitative leap in artificial intelligence technologies. Agentic AI are not just more efficient tools. They can set complex goals in a changing and uncontrollable situation and to pursue them through autonomously managing their resources. And this raises difficult questions for policymakers and even for corporate managers. There, when an AI system chooses its own sub-goal, who is responsible for the outcome? Second, how do we audit or explain a chain of decisions that was not expressly programmed by human beings? And how do we prevent unintended or emergent behaviors in a complex environment? So, when we talk about agentic AIs, we are not only talking about technical challenges, we are also talking about new governance challenges here. Let me now move to the central policy theme, that is trust. Many AI systems has been working like a black box even for developers. Users cannot see how outputs are generated. Even engineers cannot fully predict how complex models will behave in all situations. This opacity naturally creates anxiety in the society, and such anxiety can lead to societal distrust, which generates serious business risks. If people feel AI is uncontrollable or unaccountable, they may reject it, ask the government, like Mr. Ida, to regulate it harshly, and or just simply avoid using it. For companies, this becomes an existential risk. If they ignore this problem, AI services can lose public trust, and in the end, the whole industry could lose its future. Thus, we need AI governance, not to prevent harm, but to build trust. In these perspectives, I think AI governance should accomplish three objectives. First, reduce information asymmetry between developers and users. Second, create credible mechanisms for readiness. And finally, provide stable expectations for business and citizens. In this sense, governance cannot be brakes on innovation. If it builds trust, it actually becomes the lubricant that allows AI industry to scale and become sustainable in the future. So, if the trust is a goal, what is the first step? This is a very important question for the policymakers and the corporate managers. My answer is transparency. Of course, accountability is important too. As a consumer, I would like to know who is responsible when something goes wrong. But if we focus only on accountability after accident, we are always too late. We need ex-ante or before the fact transparency here too. In particular, we need to tell users 4 things. 1, what the system is designed to do. 2, what data it uses. 3, what its known limitation and risks are, and how it's monitored and improved. This is why explainability is so important here too. And it is also why we must improve AI literacy across society, including users, policymakers, even corporate managers. Today, all governments are now struggling with these challenges, especially those trying to lead in the AI industry that will shape the future of global economy. But their responses are far from uniform. First of all, authoritarian regimes and democracies take completely different approaches to these challenges. For example, in many authoritarian systems, AI is made transparent only to those who are in power, not to the public. While democracies at least try to make AI system more transparent to citizens and independent watchdogs. And even among democracies, the approaches are not the same. Very roughly speaking, we can group them into 3 broad types. First, the EU pass. This is a risk-based regulative model with a binding legislation like the EU AI Act. It focuses on high-risk use cases, conformity assessment, and strong fundamental rights protections. This provides legal uncertainty, but can be relatively rigid, and sometimes considered as not innovation-friendly. Second, the US pass, which is market-driven but sectoral to some extent. It relies heavily on the existing laws, guidance from agencies, and enforcement ex post. This can be flexible and innovation friendly, but sometimes fragmented, as I said before. Of course, I'm aware that this picture is somewhat oversimplified. The United States luckily has a 50 state government, except in addition to the federal government controlled by Mr. President, right? And it's true that some of them, especially the state of California, Utah, and Colorado, have already passed laws regulating AI. The third one is what I call the Japan-style approach. Japan does not have a huge integrated market like the EU, and it does not have a global AI giant like the US. So, staying true its long tradition of cultivating international corporations, Japan is trying to take the best part of both the EU and US model and adapt them in a distinctly Japanese way. Indeed, Japan tends to blend three policy tools. One, existing laws. Two, soft law tools like guidelines and code of conduct. And third, multi-stakeholder processes. In addition, at the international level, Japan tried to shape the global rules or norms. For example, through the Hiroshima AI process, which Mr. Ida had just explained before me, to build consensus and to protect a fair competitive environment for the future of AI. I believe this third way can be especially efficient for fast-moving technology like the agentic AI because it allows quicker adaptation while still staying consistent with existing legal frameworks. So to summarize this slide, Europe follows a risk-based hard law models, the US takes a more market-driven sectoral path, and Japan is experimenting with a hybrid with hard way, trying to blend the strength of both approaches. Okay, let me conclude by coming back to the agentic AI and the hype cycle, and what it means as we move towards the slope of enlightenment after the trough of disillusionment. First, we need to recognize the qualitative shift. From a technical perspective, agentic AI may indeed bring a quantitative lift in efficiencies, but the more important change is qualitative. When moving from a faster tool to autonomous systems operating in open-ended environment, creating new barriers, but also creating a new types of risks in terms of safety, security, and responsibilities. Second, we need to design a governance for trust. These changes in AI technology require our governance system to change too. We need governance that can handle autonomy, shared responsibility, and continuously learning system, which we have not seen before. Some of this can be handled by using existing laws and regulations where they fit, but there are clear gaps around autonomy and liability that require a new framework from scratch. And we have to focus on ex-ante risk management, continuous monitoring, and effective redress. Governance should be seen not as a constraint but as an enabler of trustworthy deployment of AI services. Third, we must invest in transparency and literacy. The foundation for trust is not only accountability after something goes wrong, but also proactive transparency and AI literacy before deployment of services. Actual AI literacy is essential for everybody, users, policymakers, and even corporate managers and employees. And different jurisdictions are taking different paths for these challenges. And I believe that Japan, which is experiencing combining hard law, soft law guidelines, and the multi-stakeholder processes, can contribute to this global effort as a kind of a third way. But the core point we should pursue is very universal. If we want agentic AI to move beyond the trough of disillusionment, we must treat governance and transparency not as a brakes on innovation, but as a base of infrastructure. Thank you very much. I look forward to the discussion.
Thank you, Professor Toshiya. Next, I'll bring to you from Silicon Valley, a enterprise level entrepreneur, Mr. Ken Carter. Uh, please. Ken was the general counsel at Google, and right now he's the CEO of an AI legal startup called Ozeki. And at the same time,
Recording
he's also,
stopped.
Now I can say all the good things.
yeah, it's all secretive stuff from this point.
91, when I was an undergraduate student majoring in Asian studies. I spent my junior year here studying Japanese culture, language, economics, and Kyudo. Thank you. So there's no such thing as a bad excuse to come to Tokyo. It's one of my favorite places. I am, as Robert mentioned, I hold an undergraduate degree in economics and Asian studies from Colgate University. I have a law degree from Cardozo Law School in New York and a master's in business administration from Columbia. Most recently, I was the general counsel to Bitmovin, not to Google, but that would have been nice. Before that, I was the head of legal at a company called Cloudflare, which has been in the news comparatively recently. Before that, I was the counsel for advanced networks at Google, which I assume you've heard of them. I started my career as a senior FCC attorney, and slightly before that as the deputy chief of the Telecoms and Media Research Institute at Columbia University. So I have founded, after being an attorney for 25 years and 10 as general counsel, I started Ozeki to help people negotiate better contracts. After having negotiated literally, with my co-founder, literally thousands of agreements. And you'll find that our technology needs to be hyper precise because a change in a single character can change the entire meaning of the clause and change an outcome in litigation. So I've come to you today to talk about the AI bubble. And yes, we are in an AI bubble, and that comes from an AI company. Just the one click at it. I didn't bring any slides. I figured I would talk not from the deck, but from my heart. So is that necessarily a bad thing? And I myself have lived through at least 2 or 3 bubbles, the dot-com bubble, the subprime mortgage bubble, and others. We typically think of bubbles in the historical context. There was a famous tulip bulb in the 15th, 16th century, a famous bubble in the price of tulip bulbs was astronomically high in the Netherlands. They were traded for vast sums of money. Fortunes were made and then lost. But anybody who's been through Schiphol Airport knows that Amsterdam is still the tulip capital of the world. So bubbles can have lasting positive impacts. The bad news is that they're disruptive in the short term and have outsized impacts. I note sort of here at the outset that there are certain unsettling comparisons to the AI bubble and as to the telecom and dot-com bubbles of the early 2000s. And I note that about half of US GDP growth in the last couple of quarters has been investment in AI. So if that investment stops, it will have an outsized impact on the US economy. Also unsettling is that top AI companies are now engaging in circular trade. They are lending one another money to purchase products from each other. When I was a business student in the early 2000s, in 2000 there was a Harvard case study. Well, in business school there are 2 kinds of case studies. There are case studies of which things that you should do, things that you should emulate. And then there are business case studies which are, don't do that again. And when I was a first-year business student, there was a Harvard case study on Enron and WorldCom. And both of those studies went from being something that you should emulate to a year later being something you should not repeat. So they're unsettling.
comparisons to the dot-com bubble of the 2000s. The good news is, unlike the subprime mortgage, it did not cascade and disrupt the entire economy. So we can just hope for that sort of outcome again. All right. What does the post-bubble world look like, and how do we thrive and succeed in that world? Well, first, I think you have to start with the idea that AI is a con. AI is a confidence scheme, right? And that is not my idea. That is by definition, right? The Turing test, which is now 75 years old, defines AI as a system so sophisticated that you cannot tell the difference between the computer and a human, right? Tells you nothing about how it works, tells you nothing about what it does. It only tests your perception of the technology. So we're going to need something better. So let me posit that we have now entered into the era of AI, where AI stands not for artificial intelligence, but for artificial insanity, right? The colloquial definition of insanity is doing the same thing over and over and over again and expecting a different result. Now, AI is probabilistic and stochastic. It is not determinative. So no matter how good Rube's prompts are, if he runs them again, unless he has the temp turned all the way down to 0, he might not get the same outcome, right? And I started to think about what's another machine where you flip the switch over and over and over again, and it produces a result that's constrained within statistical parameters, but it's not the same result. It's not predictable. What? No, it's a pachinko machine. You keep flipping the switch, the balls go probabilistically down the chutes, but you can't predict it. We need something better, right? AI hallucinates. Okay, so if you think of a definition of intelligence, intelligence is the ability to understand cause and effect. It gives us the power to predict the future and understands how our actions will affect the outside world. That's a fair definition of intelligence. AI doesn't do any of that in its current state. So here's the good news. The collapse of the AI bubble will take out all of that, and all of the non-serious actors will go away. So we have the ability to take what has gotten us to this point, which is frankly wonderful, right? I don't mean to be completely negative. I'm building a business on this technology. I'm staking my entire career on this technology. What happens? Well, I was struck by this idea. My first assignment when I was an attorney at the FCC was to write a paper about Wi-Fi. This is in September of 2002. Most people hadn't, well, many people had heard of Wi-Fi, but most people hadn't used it at that point. They didn't know exactly what it was. And so I wrote an FCC white paper on Wi-Fi and how it would impact the larger economy and what were some of the lessons for the commission. And we talked about, you know, $1 billion or $2 billion or $4 billion worth of Wi-Fi cards sold. And we were so excited. This is a big thing. The economic impact of Wi-Fi in the United States last year, consumer surplus, producer surplus, and revenues combined together was $2 trillion. And you don't even think of Wi-Fi except when it doesn't work. So we will get to a future where the economic impact of AI is astronomical, and you won't even think about it. It's just there. And you'll only think about it when it doesn't work. All right. So how do we win the post-bubble world? Well, I'd like to start by introducing a concept that hasn't been talked about today. We talked about agents and agency And Ruth gave a very nice definition of that up front. But we didn't introduce the other half, right? An agent is only half of problem. There's the other piece, the other side of this is the principal, right? A principal is someone who has an interest and delegates rights to an agent to act independently or in a limited independence to achieve tasks for the principals. And that's the approach that that we're betting on. So I hope it wins the world, right? We think that the people who can best combine data, technology, and human intuition will generate outsized impacts for their principals. And that's what we're building. We're building a system by which you can negotiate a contract without just throwing it in ChatGPT and getting back the next most probable word, but rather using the AI to help select from a set of deterministic choices, predetermined choices, in order to fake not just something that looks like intelligence, but something that appears to have discretion and acts for the benefit of the principal. This is not stochastic, it's deterministic. It will not hallucinate. There's no magic AI thinking, well, we just put the right prompts in or the right set of prompts. No, it has to be a more sophisticated, more comprehensive strategy. That's pretty much it. I hope that what I said was provocative. I hope it gave you food for thought, and I'm happy. We should probably slip into the next panel and do questions there maybe. But I thank you for having me.
Thank you, Ken. Thank you so much. I'm pretty sure you have some questions already. What we're going to do is, again, we're going to take a quick break because what's going to coming up will be a panel, and you will have the opportunity to ask questions to Ken, to Mr. Ida, and Professor Toshiya. Professor Toshiya is going to moderate the panel, okay? So we'll have more time to exchange your ideas, or even if you want to debate, you can do that too. All right, so let's take a 5-minute break, and then we'll start the panel. Thank you. now we have AI, and you know AI claims to replace us. How? Let's talk about it. Right? I do think to a certain degree AI will. I do believe in that. And I mean, one thing you look at is what Elon Musk was doing earlier this year, with what he did to U.S. government. Okay, 3, 4 young kids in their 20s and 30s, right? They did auditing to a U.S. government agency, and the amount of workload is probably 200 to 300 PwC auditing professionals work, 6 months work. And his team did it 2 weeks, right?
So the actual results in the 10 months later of Doge produced no net savings for the United States government.
Correct.
It was actually
Correct.
costly. So, but yes, AI can analyze and summarize massive amounts of data, which is extremely helpful. And right, and we use that in our technologies to our baseline contract. What we did is we had 2 law students analyze 4 contracts, and then we had the computer analyze the same contracts. The computer was 60 times faster with no increased error rate over the law students.
Interesting. See, we only see one side of the story at one particular of the time. Right? This is how the universe works so far. But let me introduce the panel. Professor Toshiya, that you're already familiar with, who's going to moderate the panel, and Mr. Anthony Colas. Again, I'm sure many of you are familiar with him. He's the head of pedagogy at 42 Tokyo. And I just found out last night he speaks 6 languages. Okay, so for Yiming in the back, try him on Mandarin. 他的中文 and he speaks Spanish, English, of course, French. French is his native tongue. Mandarin, what else? And Japanese for sure, yes. Okay. So very, very talented. And Mr. Ken Carter, you're, of course, familiar with. Ken's going to bring the corporate perspective and also legal. So this is where things get connected, right? And of course, Mr. Ida from the government perspective. So please, Mr. Toshiya, go ahead.
Okay, thank you for having us. First of all, I will give Anthony 5 minutes for the kind of icebreaker of this conversation.
Right, so hello everyone. Thank you for being here. I just wanted to take a few minutes, maybe not even 5, to first say thank you for everyone to come and to welcome you to 42 Tokyo. I just wanted to take a minute to explain what 42 is, what we do, and why we are doing this collaboration. 42 started in France in 2013 as a way of palliating the fact that we needed engineers and good engineers, and it was difficult to find them. So they created a system where it's free school. Anybody can enter after 18 years old. It's open 24/7, and again, it's free. So you're welcome. It's not a boot camp. It takes quite a while to finish what we do. But basically what we believe in is that it's not only good to be a good engineer, you also need to be good at soft skills, right? So the whole system that we built is peer-to-peer based, project-based, meaning that similar like you were a freelancer, for example, I would give you something to do, and I don't really care how you do it. What I want to do is you to make it work, right? So that's what we do, and we believe that by trial and error, you try a lot, you fail a lot, you work with your friends, and you have a good communication skill, good leadership skills, and you can do great things together. So we are open in more than 50 campuses over 30 countries in the world. And so, yes, we have a big network. We have more than 22,000 students in the world as well. A few of them are here. And yes, we are very glad to welcome AI Agentics, and I'm glad that this partnership has been already been fruitful in Paris, London, and other countries, hopefully more. And so, yeah, welcome again, and thank you very much.
Okay, thank you, Ken. And let me start by asking Ken and Ida-san first. Right? Ken, that you say that the bubble burst is not the end of the world. The Amsterdam is still a capital of the financial market, and it means that it seems to me that we do not need to worry about the bubbles or the bubble burst. So do you think that does it mean that no intervention is required to control the bubble or to control the super hype or something, that hype situation of the AI businesses? So that's my question to you. And for Ida-san, that Ken said that AI is has a very unique feature that is not deterministic but stochastic or probabilistic, right? So from the viewpoint of policymakers, it is a nightmare for you to control something that is not deterministic at all. So how do you recommend the policymakers or other agency or the corporate manager how to control such a stochastic thing under the umbrella of the good governance? This is the question for you. So Ken first.
Okay. So I guess a couple of thoughts. No intervention at this point is too late. So by the time the government can intervene and change things, the bubble will have already burst, will already been on the other side. And it may, in fact, exacerbate the effect of the business cycle, right? AI, the bubble is, if you've invested at a super high valuation in certain companies, you will get hurt. And in the short run, you will be very unhappy. In the long run, right, one of two things will happen. Like, you'll stay in the trough, and this will be a technology that's not of widespread utility. Or two, all of the unserious players get knocked out of the market, and you have this sort of economic Darwinism, where usually the best technologies survive, not always. To your point, there are, however, existing regulations and case law on hype. You can, under U.S. law, say anything you want, even if it's not true, as long as it's not, as long as it's puffery, is the expression. But you can't make material misstatements in connection with the sale of securities. So you can't say AI will cure cancer. You should invest in this company and buy this stock, if that happens to be untrue. So it's a way of protecting investors in the marketplace.
Okay, so thank you very much for the very difficult question, but I don't have, a kind of decisive answer. But from my experience, when we make some, the policy formulation on a kind of technology or any new element in society, sometimes we have already faced with some unclarity in process and also the development of things. For example, when internet came up and it spread out across the society, and all different stakeholders were involved. So the government doesn't know, what is happening where. And sometimes, we need to understand, something good for some people is something bad for other people. So we cannot regulate everything from the central headquarters, but we need to understand, diversity and also the some, the probably flexibility is a very important element here. So in every time we discuss AI policy making, I was always looking back at the internet governance policy making, and also sometimes we have to understand the difference from internet and the AI, between internet and AI. But I believe there is a lot of similarity. And also, even in the case of internet policy making, we have to understand diversity, flexibility, and also the multi-stakeholder involvement, which gives us a lot of difficulty to government. But we have to understand, we have to be, what to say, the responsive to the changes in society and also the diversity of society. So I think, AI is very unique, but we have a lot of examples in our history, and we need to learn a lot from our past experiences.
Okay, thank you, Ida-san. You talk about the historical similarity between the AI regulation and the internet regulations. I think that your point is very good. And in the internet is now the foundation of the every part of a societal lives, and it's the foundation for the every economic activities, and it's created lots of wealth for everybody. But simultaneously, it's created a lot of troubles, problems, human rights issues, right? So that in that sense, that every government say that we should control internet to some extent. But from the end point, you say that from a viewpoint of the investors or the economics, the AI bubble is just a normal thing we should not control. If even if we try to control it, too late, right? So that from a viewpoint that what the role of the government or the policymakers in the coming age of AI, they just watch what happened to the next and intervene after something happened, or they should do something. And for the call, I have a similar question. As educators of the future programmers of the future entrepreneurs of AI, what do you want the students to prepare for the coming risk or the downturn or some bad aspect of AI? And what do you want them to learn from your
Yeah, I think AI is no different than any other emerging technology in terms of its form of regulation, right? So you want to, you regulate for certain things. You regulate for market failure or the collapse of markets where you have concentration of power and they can extort rents from consumers. That's a bad outcome. So if you had just one AI company, you would regulate it as a monopoly. You also regulate to protect against other social harms, not just economic harms. For example, there was a case in the United States recently where tragically one of the large foundational models helped coach a young man into killing himself. Told him how to make the news, told him how to hide this from his support and his parents. That's not how that product's supposed to function. That is a defective product. That is a product that caused harm to its consumer. That can be addressed through traditional notions of tort liability, and I think tort liability would be really important here. And then finally, you can regulate through industrial policy, where you are providing incentives or disincentives to achieve certain outcomes. You want the government becomes a tent pole or a large consumer of the technology, so that it helps it helps provide an economic incentive to deploy it. And telephony is a long-standing example of that.
Yes, and to continue like this, governmental regulations, they want to implement things, but how do we implement them to the companies? And therefore, well, starting like this, what does the company want? Yes, they want to implement AI, they want to implement all those agents or whatever. How do they do it? For now in Japan and probably other countries, there are different issues for doing this. So first, especially in Japan, is the fear of autonomy for those agents. What is, as you said, what is the output? And depending on this, well, it can be very troublesome. if you have bad outputs. The second point being, what are your data that you based on, like whatever your company is. If you don't have good data, the output is not going to be good also. And the third point is where we try, at least at 42 Tokyo, to do is who is going to implement those agents and all those workflows. So what we do here at 42 in general is to bridge the gap between that, okay, AI is here, but you can write code as what was saying before, or you can become an architect and guide those AIs to do the work for you. And that's what we're trying to do, right? So you have to train people to use those AI, use those agents, and make them work with workflows that will give you good outputs. So what we do here is that, of course, we teach the students to do normal programming through projects, right? So they're going to touch databases, they're going to touch algorithm, they're going to touch a lot of things. So they're going to understand the different concepts of programming. And therefore, they're going to be able to communicate better with AIs and therefore have better outputs. So that's one thing. Another thing being that we are teaching them to start using AI, not at the beginning, because they have to really understand that what you give into the AI, and that's a very big difference between vibe coding and knowing what you do, is that how you ask your questions, and if you structure it in your head, the AI will be able to give you the good outputs. And to put that into perspective is with companies, if you have students that know how to do that for themselves, when they're going to go to those companies, they're going to be able to say like, okay, those data sets are not very good because if you put this, the AI is not really going to be able to sort them, not going to be able to work with that. So we should fix that. Also, because I've been working with AIs, I've been creating agents for a few years, well, maybe not years yet, but I will be able to do those workflows for you. So that's what we're trying to do.
Okay, thanks so much. But I'm also an educator in my universities. But good thing is a good thing for everybody. But still, we have a very bad actors there in the market. And for the internet, we can do many good things using the internet. But also the bad guys trying to control the opinion, the elections, and trying to say the very bad thing to the younger generations. So that can we prevent the bad thing happen from the AI world? And in that sense, I have a little bit concern about Hiroshima AI process. So I need to ask question to Mr. Ida-san. The Japanese hardware is based on some voluntary commitment, not the binding order, the binding regulations. So how do you motivate the corporate people to follow the lead of the government or the global society to make a good AI for everybody? Can give them some, can say some good award of doing good things, or pay money for them, or subsidize?
Right. Actually, no. That is the one of the biggest struggles we are facing now. As I explained in my presentation, the companies and also the developers, researchers, all those people are waiting for some feedbacks from their work when they join the reporting framework of the Hiroshima process. And now, we are trying to do some, what we explored is the possibility to incorporate a kind of incentive for companies and other stakeholders to disclose information and also follow such code of conduct, not limited to Hiroshima process itself, but the Japanese AI law has the similar structure. They require the information from companies without giving a lot of regulation from the government. But we try to collectively govern AI technology. So from that perspective, if government could provide some opportunity or incentive, such as the kind of qualification for government procurement process, or any kind of certification can be a good solution. But at this moment, it's still a little bit difficult. But I know some companies are already talking about the possibility to build up a certificate for AI technology and the safety mechanism. From government perspective, it is very difficult to start new certificate system on AI technology because it's changing a lot, and it requires a lot of expertise. We don't have such people, we know digital agency had a lot of struggles to hire good people from outside, because the salaries provided by the government and the private companies are so different. So it's always very difficult for the government to gain a good expertise. But that is the reason why we need to collaborate with different stakeholders, with the business and the academia and civil society to work together, share the information expertise, and build up the kind of governance framework together. So I think even if when the government wants to provide some incentive, I believe we need to collectively work with business people and the academia together, and probably I hope there is a time to start the kind of certificate mechanism, but this will not come from the government itself, but this should be built up from the business efforts and probably together with academia.
Ken, do you have any suggestion from the billionaire side? Or billionaire side? Billionaires. Or corporate side?
Oh, business side.
Yes.
Yeah. I kept hearing video. So I'm thinking through your question about basically about fraud, right? AI is ripe for deep fakes and defrauding people. U.S. politicians are using it right now in all kinds of unsavory ways, and that is only going to get worse. And the question is now, when you go to enforce that, when you go and enforce notions of fraud and scamming, how do you attribute responsibility, especially if the software is completely agentic, right? You can't. It's like the problem of the corporation, right? Corporation is under U.S. law what's called a juridic person. It has all the rights and obligations of a human being, but it has no body to incarcerate and no soul to save, right? So how do you take something that is a thing and punish it? It's not an easy question. I think we will revert back to like who is in control. Yes, you wrote the software that wrote the software that wrote the software that wrote the software that did this bad thing.
Cut
right?
the code.
Yeah.
Cut the code. I'm proud of the power.
Right, but now that this bad thing has happened, how do we attribute liability? How do we put someone in jail? Do we fine them? Do we do both? And I think the bottleneck becomes the machinery, right? Everything has to run on a machine. And the machine is owned by a person, a corporation, and what happens on that machine is that organization or individual's responsibility, unless there's been, the machine has been compromised and someone else is nefariously running code on that, in which case the question becomes, well, can we find that person? And should you have taken better steps to ensure security of your machine?
Thank you. Okay, let's go back to the economic aspect of the questions. So I spoke about the track of decision, and Ken talk about the bubbles, and we should not worry too much. We should not too much worry about bubbles because Amsterdam is still there. So that I give it to you. The very last question is, what is the single most important actions we should take to make sure that the agentic AI survives the bubble or and becomes a trusted infrastructure in the future in the world, or in starting from either side.
Sorry, I didn't expect this question, but actually, personally, I think I don't fully understand, the AI bubble, because, for me, AI is, something inevitable coming to the society. So maybe, a lot of people are talking about AI at this moment, and maybe less people will be talking about AI in coming month. But AI is anyway the prevailing into the society, and there is no downturn of proliferation of AI. So I from my perspective, I don't worry about AI bubble.
Thank you so much. Okay.
Yeah, so I actually did come prepared for this question. What I have is I've created a policy proposal, an unpublished policy proposal for a light touch intervention in regulating AI. Without going into the details, because we're really over time, it's basically using Isaac Asimov's 3 laws of robotics and applying them to AI development and coupling that with an enforcement mechanism that looks like traditional notions of criminal law and tort law.
Very quickly, as everybody said, AI is not going anywhere. It's like any bubble. There are still tulips, there are still internet, there's still crypto. It's just different use cases. So AI's agents will be there. Maybe the correction will make it so that we will keep only the best parts and make it work better.
Thank you so much for the Ida-san and Ken and Anthony for your great insight. Thank you so much.
I think we're going to open up for some questions. It's been almost 3 hours, so thank you very much for sticking around. And any questions at all, please. Thanks to our lovely Julie over there. She's going to pass the mic to you. Any questions, please?
Thank you to all the panelists. I really enjoyed all of your talk. So I would like to bring you to the couple of years back with Cambridge Analytica. So during that point of time, AI was not that prominent or agentic space. But if they had tools like what we have right now, things would have been much more sophisticated. So on one hand, Mr. Yoishi mentioned that you are not trying to regulate AI in Japan. But with the guidelines, do you think you can stop malicious actors using AI for malicious purposes? And Japan is a global country with exports all around. So in EU, I work in the European Union, not in the European Union, but I work in Europe, and we have a couple of projects there. They are very much going after AI and how you can regulate AI across various spectrum. So how do you balance it out? Because Japanese exports are going, both technological exports and others are going outside Japan. So how do you see some kind of a uniform AI standards or regulations coming about to guide it? And how do you address the malicious actors using AI for a malicious activity? And to Anthony, I'm not very familiar with 42. This is the first time my exposure. Do you see AI taking on more as a tutor? Do you see your lessons? I don't know if you're already doing it. Do you see, AI or ChatGPT kind of chatbot-based AI systems taking on courses and providing lessons and evaluating? Thank you.
I guess I'll start. Concerning AI, as a French person, I know exactly what you mean. We like to monitor everything, make laws for everything, for your first question. And I think there is a quote from I don't know who said that, but I think it was very on point, is who's going to make AI? So there is Americans, of course, with OpenAI, Anthropic, whatever. There's the Chinese, which have a different approach, but is very successful as well. And then there are the Europeans who are irrelevant because they're just trying to regulate, but they didn't build anything. And I think that's kind of like the point. You want to regulate things. Well, yeah, well, that's my point. I mean, nothing against mutual, I think is good as well. It just depends on what you want to build. And before you have a good product, you can try to regulate it. But as we talked before, it's very difficult to push on those regulations, especially if you don't have the products to make it work yet. Maybe someone else will comment on this, and then I can answer the 42 question.
Yeah, thank you, Professor Antwip, to bring up this question, because I had a blunt question wanted to ask. Can governments effectively regulate AI? And how? I'll give a little bit background on this. Among the foundation leadership, Ruth can, of course, at different times, being devising different governments on AI governance, AI policy. Ruth, for a fact, drafted AI policy for, I think, Liberal Party in Canada. And I was in Indonesia, Malaysia, those ASEAN countries. There are panels I moderated. There are government officials talking about AI. They're very knowledgeable, very talented in managing budgets, national budgets we're talking about. But somehow I feel a disconnect between AI technology and their vision of how to manage. Simply because a lot of the AI we're talking about are in AI coding, binary, and the code. For government officials, I'm pretty sure they've never coded a single line in their life. No, I don't mean that in any negative way whatsoever. Because we're human, okay? We're biological beings, and we focus on certain areas. And some of us are very talented, okay? History, they're geniuses. They can do so many different things. But somehow the vast majority of us only focus on some areas. So right now, I mean, we always talk about opportunities and challenges AI bring to us. But what I see is, for government officials, without understanding coding, AI coding, how do they regulate? That's my question.
In theory, that it's very difficult for the government to control production unless the government can control some critical input. For AI, AI is generated by the human beings and some code and PCs and broadband internet. So it means that anybody can generate his own AI everywhere in the world, outside the jurisdiction. So basically speaking, the government cannot control the AI production. However, government can control the access to its market. That's how the Europeans are trying to control the AIs. They try to control the AI when they start providing services in the jurisdictions, I mean their citizens. That's the only way I can think of that the government can control AI services or agentic AIs.
Yeah. So two thoughts very quickly. One, most people can't write in machine language. That's the actual ones and zeros that the computer operates in. So you need to write in Rust or Go or Python or something like that, and then compile your code into machine language. And that process has been around since I was learning how to write programs in the 1980s. AI builds one more layer on top of that, right, where you prompt the AI to write in Rust or Go or Python or whatever, and then compile it. So it's one layer abstract back to natural language. So it opens a world to people who can think logically but don't have the time to learn how to write software. in that vein, when I was an FCC staffer, as I mentioned in my talk, I was the commission's expert for unlicensed devices, for Wi-Fi basically. And there were other people in my office who were working on other parts of radio spectrum policy, spectrum auctions, licensing, those kinds of issues. And somehow I got it in my head that it would be a really good idea for the lot of us to go and get ham radio licenses and become licensed by the commission to be radio operators. And so we went and we enrolled in the class and we took we were so afraid that we were going to fail the FCC test as FCC employees. And there were 4 or 5 of us who went out and got ham radio licenses, and now we understand not just how the technology works, but why drip loops are important and how to do the isomerization. And now we have a detailed understanding about the stuff that we're talking about from an economic perspective. And I think that's really a role model, for, a path for regulators should, I don't know, come to 42 and learn how to write software.
Yes, indeed. And also to come back to your question, which goes after that, is we can see in the market, like especially in the United States, junior developers are getting rid of. And the reason was because you can do most of the junior work with someone that knows how to talk to AI pretty easily. And that's why, though, you have a surge in the senior positions, because one senior who knows how to navigate AI and how to prompt it and how to work with it is 10 times better than, well, let's say 10 developers without AI. And so to answer your question is AI good for learning? And is AI, should you use AI for learning? Of course. But the problem that we see with the students is it's very easy to be complacent in a way that you think you know, but then when same as the students, when they have their exam, without internet, without talking to each other, without any sort of help, well, they struggle, right? Because it's, of course, like when you talk to someone, especially if the AI is always telling you, oh, you're so great, you know everything, blah, 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 and then you think you know, and then, well, you actually do the work, you don't. And so that's why what we do is we do it at the beginning, no AI, and then we incrementally increase it.
So my perspective is, may not be, a kind of common understanding across the government, but from my experience, when we started the AI governance in OECD, people talked about, the AI, works in a specific context. So, even the same models or systems may produce different outcomes in different contexts. So we would not intend to regulate AI itself, even coding itself. If there is any one right way of writing a code, and people come to us and tell us, we will regulate coding, but we believe there should be a lot of different ways of coding. So we don't regulate coding, but we may need to regulate outcomes from specific models or systems in specific context. So that is something people may call sectoral approach. And we look at the different sectors and different use cases, and we try to understand, when we need regulation and when we can leave the different ways of use of AI technology in different contexts. So that is why we try to avoid horizontal regulation across sectors. But we try to depend on different sectors and the different regulations. If you look at the different sectors, we have so many different regulations. We have more than enough, in medical care, in finance, so they have their own systems, and when they incorporate AI models and systems in their business or in their ways of doing things, you know, they may find, you know, they need regulation. In that case, you know, the different regulators in specific sectors should create a new way of regulation. But we believe, you know, it's very difficult to regulate AI across sectors.
Thank you. I will give one example, specific example, is that in AI coding, we use AI to optimize code because it does 10 times, 100 times faster and better. At the same time, there's one scenario where Ruth found out AI actually modified not only the regular code, but also the licensing agreement. So think about that. Okay, this is where there are, I think, regulations, governance needs to be in place, and this is where perhaps jointly between 42 and Agentics Academy, we should have a training course for government officials, because it's a learning experience for everybody, right? We need to learn what AI is. Please.
I'm kind of amateur for the artificial intelligence, so my question is a little bit a more political thing. But you were talking about the regulation. It's more like a transitional regulation based on the technology right now. So I wonder if someday AI technology will approach into really perfection, and then we don't need to regulate anymore in the future. This is my question. Is it okay?
It's a very interesting questions. AI is regulated because it's new, I think, because it's a kind of black box, so everyone has some anxiety of how the AI will behave in the uncontrollable situations. That's why we need regulation in the very first time. So the basic is that the primary purpose of having a regulation is to ease the anxiety of the market. So that once AI becomes perfection, meaning that there's no anxiety and people can understand that the literacy level is high enough, I think there's no particular regulation targeting on AI. We need some regulation about food products. It shouldn't be poisonous, and some some regulation on the good agentship and good regulation on the safe automobile, but not a particular regulation on AI, because AI is everywhere, and we cannot distinguish the product which is made by human only or made by AI, because AI is so perfect. We cannot distinguish the outcome of AI from the outcome of the human being. So there is no need for pure AI regulation anymore.
Very good question, okay, because I think fundamentally there's one thing we need to understand, which is who runs the show, humans or AI? Why? Because if it's AI running the show, AI wants to regulate us, right? And because in AI's eyes, so many things, I'm sure, in human societies today are not optimized and dumb, clumsy, and stupid, for sure, right? So it's all perspective, in my view.
Any other questions? Oh, we got lots of them.
Hi, thank you for the talks. I was curious about the Japanese activity on the regulation thing around OECD whatsoever. Have you guys, or maybe in OECD, ever reached groups like, say, non-profit standardization groups like W3C or Electric Frontier Foundation or something like Creative Commons, Japanese consumer groups or whatsoever? I think they have some good ideas on how to give better feedbacks. Feedbacks from the different perspectives.
Yeah, thank you very much. Actually, you know, the OECD is an organization for kind of policy discussions, So they distinguish themselves from the technology community. So they have a good communication with other groups such as IEEE or IEC or even ITU or other UN bodies, but basically they don't discuss technological aspects of policies and also the standards, but they sometimes collaborate with those communities.
I want to ask about so like in the past in Japan, there was a guy who developed a tool, and then he's arrested because the tool is used in wrong way, but like he doesn't have any responsibility for it because like and then here's the question: so what is the good way to prevent getting arrested by I mean, like, I'm not gonna do like bad stuff, but like, I just want to like support the development, a developer. So, yeah. So, what is a good way to prevent? Yeah.
I would say first it depends which jurisdiction you are, because depending on, let's say if you're in America or in Japan, it would be a totally different mindset. So let's say if you're in America and you hack something, maybe people will say, good job, I'm gonna hire you. If you do that in Japan, they will say, bad job, you're gonna go to jail. So that's something to have in mind. And also, I think it's the topic that we said before is indirectly, like, did you have control about the output? And what about the current jurisdiction, as you said, right? Is like, if in Japan it is said that whatever tool you create, whatever it does, that's your responsibility, well, then nothing you can do, right? But yeah.
So under U.S. common law, which descends from actually British law, and I don't know enough to speak about Japan, there are two types of crimes. There's strict liability crimes, and there's mens rea crimes, right? And a strict liability crime is you did it and you're liable. So if you're in your car driving 100 kilometers, but the speed limit is only 60, doesn't matter what you were thinking, you broke the law. But if it's something, other crimes have what's called mens rea, and that's just Latin, it means guilty mind. And did the analysis turns on, did you intend to have the specific intent? Did you want it to do this? And did you do that with malice? And if those two conditions aren't present, then it is probably not a crime. Like you made a mistake. You might find yourself civilly liable. You have to pay damages and fees and all kinds of unpleasant things like that. But you don't go to jail.
So to resume, talk to a Japanese lawyer.
Any other questions? I have one last question, and this one's around cybersecurity. I'm going to put my cybersecurity hat on here for a second. Obviously AI is opening up a lot more vulnerabilities to everyone involved. I guess this question would be for maybe Ken and Anthony. How are we seeing AI being used as for defense, right, in the market, right? Is that a market for folks? And for Anthony, is this something that maybe students of 42 want to focus on as kind of a pathway? As much as it's exciting to build, how do you always also learn how to protect?
In terms of cybersecurity, speed is everything, right? So when you have a breach, detecting that breach and curing that breach as fast as is possible so that no data gets exfiltrated, nothing further goes wrong, speed is essential. And if you have a human operator, that delays your response time. And so there are a bunch of technologies out there, and there's one company in our TechStars cohort who was developing this, is using AI to statistically detect anomalies and address them faster than just the human alone. And so you're basically doing huge data analysis.
And to continue like this, I think recently GitHub, which is basically a service that you can put your code into, they launched a service where they will analyze what you push and they will tell, oh, you have a big vulnerability, please take care of that. In terms of students and people who are creating softwares, it depends on do you know what you do or not, and what are you building? Because if you build a normal website, well, I mean, what do you risk? You don't have any databases, you don't have any big risks. So if you spend 80% of your time trying to do, try to protect your website, maybe you could do something better. But on the other side, the problem that is if you don't know what you're doing and you have databases and you have all those kind of like important data that people can have access to it if they know what they're doing, this is a problem because you need to know and ask the AI to try and fix that, right? Or at least checking by yourself, checking that you don't have any vulnerabilities. And this is a big issue. What we see AI slop is because a lot of people, they have a good website, a good front end, but maybe the back end is totally bad or something, but you don't really see it because it's in the back. And so I think it's much easier to hack with AI than to protect. And the reason why is because, well, if you want to hack a website, you can just ask the AI and it will do the groundwork for you. But if you want to protect the AI, you need to know, okay, what do I need to protect in order to be successful? And that's why I think 42 students are probably better at doing this. And to react to what we were saying before, as I think the future of engineers is to be code reviewers more than coders to begin with.
AI is a kind of general purpose technology. It's employed by everybody, so that the malicious actors and the protectors both hire AI to facilitate their abilities. And the good news for the student is that Japan has some institute called AISI, AI Safety Institute. It's dealing with some safety issues and security issues about AI usage. And according to the news coverage, they try to expand the size of the agency by 3 times. So there's a huge job opportunity for the student in near future.
All right. Thank you very much. Any last question at all? Thank you for surviving the 3 hours and 19 minutes, actually. So we're going to take the last question. We'll wrap up.
Hello, guys. I'm a medical student and also studying at 42. And why I am doing this is because I believe that the innovations comes after indisciplinary learning. And the thing is, I try to balance, my knowledge in medicine and my knowledge in computer science. But sometimes, I'm becoming like very complacent, like, I'm, how to say, like, it's very hard to, in my mind, I feel like I'm doing my best to balance two, very different fields of knowledge. But, and also, it's really easy to say I'm doing indisciplinary, learning on my resume, like on surface. But, like, in deeply, like, the thing is, how can I say? Like how I cannot see, where I am in 10 years, simply because I know, I know I'm not balancing the knowledge of 2 different fields. And it's very hard to, studying medicine in my medical school as well, but like, if you were me, like, how would you guys do? in this situation? I know it's a very stupid question, but yeah, I just wanna get some advices for my career. Yeah, and I know you guys are so awesome. Yeah.
I don't know I can answer or make any advice, but I understood, you were wondering how you can keep the good balance, not in your knowledge in two different fields, but how you distribute your limited time in studies in two fields.
Yes,
So
and also
in my experience, I had the same question in my career. I want to learn, coding, and I want to learn algorithm and AI, want to understand more. But I didn't have any time to consume for studying, coding or algorithm. But I had to concentrate on policy making and talking with my colleagues from different countries. And so the time is limited. Your body is one, so you have to choose. And maybe I cannot advise you should concentrate on this, but you have your own expertise, and then maybe you can complement your expertise by doing more studies on coding or algorithm or AI or whatever. That's my way of thinking, and I don't think that's the only answer, but my understanding is what I say.
I'm a lawyer by training, but I also went back and got an MBA. And I often say that I'm not the best lawyer in the room, and that's often more often true than not. But I'm the only lawyer that I know who did a data envelope analysis to determine who the best negotiator was based on inputs and outputs. And so if you can use the tools of one of your discipline to answer the questions in the other discipline, that is a really good use of your time.
Very quickly, also, I think we live in a fear of missing out society. And the reason why you're asking a question, I think I understand, is because doing medical law, well, first, is one of the most difficult things you can learn, right? And the other part is 42 Tokyo and 42 in general is a very heavy cursus as well. So you need minimum 30 hours per week to learn how to code. So it's not like something you can do 1 hour per day or something like this. And that's why juggling the two might be very difficult. But I would say first, tap yourself in the back because what you're doing is already more than most people do. So give yourself some break, and also know that you don't know what in 10 years is going to look like, and probably 80% of the work that exists today is not going to exist, and new ones are going to come up. So maybe you will see how you can use that. Yeah. So good luck.
Okay, so it's a short answer, very short answer. Ask your ChatGPT. and long answer is that AI is educating themselves by following the human histories. So that they learn from lot of stuff from the internet or other materials in the library or something. So that it means that AI is following the path of the human. So if you can really think of new things, combine the very different stuffs. So that is the strength. You can survive by doing this knowledge. If you follow the others' knowledge, maybe AI, you can't compete with AI. So that's my answer. So I'm very happy to be very close to my retirement. I'm not necessary to compete with AIs.
First of all, oftentimes I do wish I were a younger person like yourself. Yes, you will face choices, sometimes very hard to make, but at the same time, meaning you have, so many options. Okay, so cherish that. Number two, I will highly, highly encourage you to learn AI as much as you can. Why? You probably already know from many of the AI, pioneers, including Sam Altman from OpenAI, Anthropic CEO, who made some announcement not just a few days ago. Medical, is going to be one of the first fields that AI gonna make drastic changes, right? I think Sam Altman even said human society are expecting to cure all the diseases in the coming decade, right? So, cross fields, interdisciplinary study, I think are going to be a common thing for students in the coming years and decades. So we all need to learn what AI is. There are lots of myths around it. Like Ken was saying, I think it's no different than all the other emerging technology, but it's at such a scale and an impact that we probably have never seen before. Okay, so that's my 2 cents. Okay, we're gonna wrap up. Thank you so much. We're gonna stick around a little bit if you want to talk some more. You're more than welcome. Thanks again for coming, and hope to see you again sometime soon.